And welcome everybody to the Daily Space Weather. I'm your host Dan, aka Smash-a-Mash, coming at you from the Smash News Network, least busted name in news. And we did see a C-class flare here from Sunspot 3068. We've got some interesting information on earthquakes to show you, and lots more as we typically do on our Daily Space Weather videos. We'll also be including some Earth weather information, so stay tuned for that. It's only the most detailed imagery of the sun and space weather you'll find on the internet. Solar flare coming from that region. And a little bit of growth here, but a downtick overall in solar activity since yesterday. Here's a solar magnetogram. That Sunspot 3068 has grown a little bit since yesterday. Here's yesterday and today's imagery. And let's go over volcanoes. Stromboli erupting, and a lava flow showing up there in this. There's an image of it, Stromboli. And a little increase in volcanic tremors happening there prior to the eruption. Askja in central Iceland, the area continues to inflate. Although not a lot of seismic activity at the moment, keep in mind the inflation could continue for extended periods without an eruption. Abico continues to produce a 10,000-foot plume of volcanic ash there. Flight level 100 over Abico. Sakurajima, flight level 050, 5,000-foot ash plume from Sakurajima. Unknown volcanic ash plume from Suwanosejima. Please don't pole vault the caldera. Semeru exploding. That's on the Isle of East Java, Indonesia. 13,000-foot ash plume as Semeru explodes. It's a flight level 130 going down to Colombia in South America. We see some explosive activity from Nevado del Ruiz, flight level 210. It's a 21,000-foot ash plume. Similar size ash plume there from Sangay in Ecuador as Sangay explodes. Also Revenador exploding in that same nation. Flight level 160, a 16,000-foot ash plume. And Sabancaya exploding, flight level 220 from Sabancaya. And we've moved our earthquake coverage toward the end of the video. You'll find out why in a moment, and we're going to speed up the pace a little bit here as we are coming at you a little bit later than we normally do. So here's the last 24 hours in 171 angstroms. This is actually slowed down to half the normal speed. That's 15 frames per second instead of 30. And let's take a deeper look at the closest star. Here's the normal speed we usually show, 30 frames per second. And we are expecting a coronal mass ejection to strike both tomorrow, July 30th, Saturday, and Sunday, July 31st. We're expecting it midday tomorrow. The 10.7 centimeter radial flux now down to 93 solar flux units. There is the 1-year chart of the radial flux. It's this black line. And for those of you used to watching the channel, you're well aware of the fact that it's the most proportional data set we have to sunspot number. The upper chromosphere and lower corona emit radio frequency. It's a 10.7 centimeter radio frequency. And here's the Space Weather Enthusiast dashboard. It looks like later in the day, NOAA forecasting a KP4. No indication of why that is. We're expecting it a little bit earlier, but hey, that's okay. That's close enough. We are expecting something like a KP4 from a glancing blow from a CME. Next, looking at Earth's magnetic moment from space, it's a geomagnetically calm situation. We've got fairly homogeneous magnetohydrodynamic pressure around the planet. The scale you're looking at here is just that, magnetohydrodynamic pressure, nanopascals. And we like to show that daily just to remind people that Earth has a thing known as a magnetosphere, and it's not going away anytime soon. Next, Earth's magnetic moment from the ground. Both of these geospace magnetosphere movies are the last 4 hours. Earth's magnetic moment from the ground here is shown in nanotesla. It is a model based on the space weather modeling framework. If you want to read about that, head to the Geospace Magnetosphere Movie or Ground Magnetic Perturbations page. Scroll to the bottom. Click on Details. You'll find a link to the space weather modeling framework. It will tell you about all the variables used to create this model. Again, that's the last 4 hours. Things are geomagnetically calm indeed. Planetary K-index at 1 for the past 12 hours. And let's take a look at the real-time solar wind. Real-time solar wind, pretty calm as well here. Some little minor perturbations happening here in the past couple of hours. You can see some fluctuations happening in the plasma temperature, an indication that these signals are legit. Current conditions are about 6 protons per cubic centimeter for the solar wind density, solar wind speed about 349 kilometers per second. GOES magnetometers are pretty smooth here over the past 2 days. Nothing to write home about there. And let's take a look at the heliospheric current sheet. The plasma from the sun is polar. Earth remains in a south pole current sheet. And we are getting more and more likely to see a north pole current sheet make its way here. You can see that in green. South pole current sheet shown in red. Let's take a look at the sun's line of sight field plot. Also the solar magnetogram showing up there as the south solar polar field migrates a little faster than the north one. That's solar cycle 25. North solar polar field migration a little bit hesitant. Let's move to coronal holes. And we have some better defined south pole oriented coronal holes there in the southern portion of the Earth facing solar disk. And some north pole ones finally rotating in here. Behind that right there you can see them just rotating in at the last bit. There's the last frame. You can see some green showing up there. That's part of the north solar polar field, having already migrated all the way down there to the southern hemisphere. Before we get to sunspots, let's talk about our featured product of the day. It is Mensa. And yeah, I've got a Mensa hat right here. Go out and tell your friends and foes to make Earth not suck again. Now, what I'm actually wearing today is, well, I can't talk about it. Can't talk about it. Can't say certain words on YouTube. But I can definitely say that, well, what I'm wearing is our best seller on the entire store. This is our third best seller, I think. Do Not Pole Vault the Caldera is number 2. And yeah, go out and tell your friends and foes to make Earth not suck again. It's a message of personal responsibility. Because it's up to you to make Earth not suck again. Since certain bureaucrats have demonstrated over the past, well, pushing 3 years, that they are incapable of making Earth not suck again. In fact, many of them are to blame for making Earth suck. Make sure they're accountable on any scale that you're able. Keep in mind, folks, our finest days lie ahead. Don't forget, if you want to support the channel via subscription services, well, check us out on smashomash.com/smashteam. It's superior to Patreon, and that post there is only for gold and silver level subscribers. They pay us a few bucks a month to ensure the probability, to raise the probability that these videos will remain publicly visible and free for all to view. So welcome to the Near Renaissance. Help us out by clicking on the home page, visiting our Redbubble shop, picking up some merch perhaps, becoming a Smash Team member. There is a bronze membership also, that's free. And indeed, we are composing a paper explaining plausibly the mechanism underlying the solar polar field reversal and sunspot cycles. If you can only support us by pressing like, subscribe, share, leaving a comment, etc., please do. Thanks to everybody who has. More information about some posts on our channel coming a little later in the video. So, last but not least, here's our coronal hole imagery. It's 193 angstroms wavelength from the SDO. You can see those South Pole-oriented coronal holes there. Much better defined today as they rotate toward Earth. Next, moving to sunspots. Again, sunspot 3068 has gained a little bit of complexity here since yesterday. And we may see some flaring from 3062 as well as it approaches the limb. Otherwise, a downtick in solar activity for the most part for the past 24 hours. Here's our solar continuum. We'll show this more closely. Here's a closer image of that. And again, we did see a little bit of flaring from sunspot 3068 earlier this morning. And we've also included a 335 plus 1700 angstroms composite series of images from SDO. That just looks spectacular. And let's continue on here to the GOES X-ray flux. So peak flux of this flare was around 4:30 this morning. It was a C4.27 X-ray flare. And here's a slowed down series of images. We'll advance this to around when that occurred. So there's that C-class flare in 94 angstroms. We've also got a zoomed out view at full speed. This is 30 frames per second. That one was 15 frames per second. We slowed it down for some close-up flare viewing. Just great imagery there from the SDO. It didn't produce any spikes in the proton flux. No relativistic particles showing up at Earth yet from a result of that flare activity. Here's our star chart. Today the sun will be passing through Gemini and Taurus and Pisces. Next, we'll do a solar system forecast as we do most days. Keep in mind, this map is not to scale, and the planets are not going to kill you. There's where things will be in a week. We'll be at about a quarter moon, a first quarter, moving from a crescent waxing to a gibbous waxing by August 5th. And here's some coronagraph imagery. We did see some additional coronal mass ejections, and while we are expecting a strike tomorrow and another one on Sunday, I don't believe we've got any more headed our way to forecast in this video. So that was yesterday's coronagraph imagery. CME off to the west there and another one off to the southeast. Here's today's imagery so far. Again, I don't think we have any additional CMEs headed toward Earth at the moment. Let's take a look at Lagrange 5 and Lagrange 1, the locations of stereo A here on the left, and the SOHO-LASCO C3 here on the right. So for you new viewers, Earth would be off in this direction. We're using the Integrated Space Weather Analysis Center for this imagery, by the way. Earth would be off on that line approximately. And I don't think we see any additional ejecta. Well, there might be some additional ejecta there. I think it is off to the west. So let's check here. And indeed, I don't think any of that CME is headed toward Earth. Looks like there's a little missing data there, but not too much. So we can expect some minor geomagnetic unrest, possibly a low-grade geomagnetic storm midday tomorrow, something like that. And here's the Altaide Spain hydrogen alpha imagery. We show this to show filaments, and we're seeing a little bit less filaments, but some filaments around the limb of the sun. So that's what's going on there. And how about the GOES 16 SUVI? This is the last about 2.5 hours. And we regularly stream this live to our Twitch channel, by the way. And let's continue on here. We don't want the video to be too long. Here's the full disk view in 335 angstroms. bonus feature segment is next. We're putting it all together so that you can just view all of the content on one video. So here's our bonus feature segment, looking at the satellite's community dashboard first. And no charging hazards at the moment. That's a good thing. Likelihood of communications breakdowns is kind of low. Here's the GOES electron flux over the past 3 days. Pretty smooth there, making it into warning levels, at least the GOES 17 was. Past couple of days, no major electron warnings. And more about electrons coming. Here's the relativistic electron forecast model. Keep in mind these measurements are made through a radiography, and the GOES 16 and GOES 17 are in a geosynchronous near equatorial orbit. The measurement is endeavored to be made at the ionosphere level, which is only at about 300 kilometers of altitude, thousands and thousands of miles lower than the location of those satellites. That's NOAA's forecast model. Here's the one-year chart of the electron flux. Let's take a look at the ionosphere, the bridge between Earth and space. The F flare is located at about 300 kilometers of altitude. Here's the vibrational frequency of the ionosphere. And some fascinating information coming about the ionosphere. I don't know why it paused, but we've restarted it for your viewing pleasure. So that's what's going on in the ionosphere. I certainly see some low-frequency anomalies and some pretty significant swings there, low to high frequency, around places like South America. And let's show the anomalygram as well. Here's the anomalygram showing anomaly in megahertz from the 30-day median. You can see these low-frequency anomalies around the South Atlantic anomaly, which is located right about here on the South American continent now. That anomaly does move. That's the weakest point in Earth's magnetosphere. You can see some pretty significant swings there of the anomalygram. Also some significant swings over Africa. And here's the latest image ionogram, 10:15 universal time, 10:15 universal time anomalygram, and let's continue on to cover earthquakes. So here's the earthquake situation over the past 90 days. We did see an end to the 7 magnitude earthquake drought. And check this out. This is the, well, this is first we're going to show the USGS map. So things have been pretty calm here over the past 24 hours, quite calm in fact. Although there was an earthquake in West Texas. Let us know in the comments if you felt that quake, not too far from El Paso. I think the largest quake of the past 24 was this 5.8 at Papua New Guinea. Also, the Izu Islands of Japan saw a 5.4. Besides that, again, pretty calm. Not many earthquakes, and certainly no big earthquakes over the past 24 hours. Now, we're going to look at the total electron content forecast next. So the total electron content forecast is the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And, well, the total electron content, turns out, shows us a little bit more than just GPS errors. Now, keep in mind, this is all of the electrons all the way up to the location of your GPS satellite, which is just inside the outer Van Allen belt, the inner portion of the outer Van Allen belt. And there's special importance to the total electron content of the ionosphere. So one layer of this is a little more important than the rest, and we'll explain why here in a moment. Let me zoom that out a little bit so you can see the time and date stamps. There we go. We'll let that play through a second time. We've got low electron contents at the moment. So GPSs will be working fairly well here, fairly predictably around most of the planet. And it turns out that anomalies in total electron content are maybe a little more important than you might realize. So if you've never checked out our community posts, head to youtube.com/smashamash and click community there from the home page, and you will find our community posts. So we've put up this video here. Shout out to Diamond. I don't know why he named the channel Magnetic Reversal News, since I don't even think he believes there's a magnetic reversal occurring. I know we certainly don't. But saving lives rocks. And that's a boom. Anyway, there's a video here about earthquake prediction using the total electron content. Turns out there's an 80% accuracy here for forecasting earthquakes up to about 2 days in advance. So that's pretty interesting. And it may tell us something about the physics. And we certainly hope it does tell us something about the physics, because forecasting earthquakes is a big deal. So maybe check out that video. Again, you can find that on our community posts page. I didn't mean to click that. And let's continue on. The heck did I do there? We are not trying to customize the channel. All right. All right, let's continue on here. Again, we are streaming live, folks. So here is the latest solar intensity gram. We'll press refresh so you see it happen. And here's the latest colorized magnetogram. And we'll look at the state of affairs from Sunspot 3068, since it's been the most flare active region on the closest star. There's the magnetic field. It has gained a little bit of complexity and size since yesterday. Those umbrae are spreading apart a little bit. The leading portion rotating a little faster than the trailing portion. Here's the full disk view. I would say Sunspot 3068 remains the most likely place to see large flares. We'll close out our space weather section with this composite series of images from SDO. That's yesterday and today's imagery. And let's move to the realm of meteorology. Yes, meteorology. And we're starting things out here on meteorology at the Smash News Network, least busted name of news. Let me check the life of the stream. We're looking at wave height. And the biggest waves in the world are currently located there off the coast of Antarctica in the Southern Ocean. 38-foot waves going on right now. And that's one of the many features of nullschool.net. If you click ocean, click waves, and click significant wave height, you too can see where the world's largest waves are located. And that's currently where they are, in the Southern Ocean near Antarctica. So here are the surface winds of this side of the planet. A strong low here in between Australia and Antarctica, and a weaker low here near the Philippines. Here are the jet streams of this side of the planet, and we show meteorology to show a global perspective. At the end, we zoom into a U.S. national perspective, and we focus on the physics of weather. We hope you're able to forecast yours. Here are the jet streams of the Americas. We've got an incoherent jet stream in the western portion of the U.S. and a convergence in the northeastern portion of the U.S. Anticyclone has now moved out into the North Atlantic Ocean. You can see this, once again, clockwise rotation happening there. That is an overall upper-level high-pressure system. Here are the surface winds, like sands through the hourglass of time. These are the surface winds of our lives. Here are the surface winds of the central world, Europe, Africa, and the Middle East. Strong low here south of Africa as well. Here are the jet streams of this side of the planet, blowing backward over North Africa, the Indian Ocean, and even portions of the North Atlantic. Let's take a brief look at Saharan dust, as some has been making its way across the Atlantic Ocean. Here's the Duex. That is 550 nanometer dust. There you go. Some Saharan dust making its way toward the Caribbean It looks like it's slowing down here and spreading out. Here's your weather.gov map, and we've got additional flooding forecasted here, including some flash flood warnings for places like southwestern West Virginia. I know there's some bad times happening in eastern Kentucky for sure. Also some additional flooding forecasted here for places like the Texas Stovepipe, the Oklahoma Panhandle, southwestern Kansas, and large portions of especially Arizona, New Mexico, Utah, and the southwestern portion of Colorado. Much of southern Colorado, indeed, under flood watches. If your county's lit, click your county from weather.gov. We don't have enough time to go over all of that, and let's just take a look at the total accumulated precipitation forecast here. The model was not available when we did show prep, so we'll bring it up now. We'll create a GIF animation for you. And some additional flooding forecasted here for Oklahoma, northern Mississippi, portions of Arkansas, and Louisiana. Rain totals are shown here in inches. That is the GFS 72-hour total accumulated precipitation forecast. And let's continue on. Here's your NASA GOES lightning mapper. That's the past about 10 hours. And July continuing to remain a quite active month for lightning. So here's lightningmaps.org. This is our real-time lightning map. Putin's lightning continues over here in Russia. And we've got some active cells in the U.S., so let's zoom in on those. Some lightning north of Memphis there. Some active cells. Those are the likely thunderclaps propagating. And let's continue on. This video was originally streamed live to Twitch thanks to our Twitch followers. Twitch.tv/SmashoMash. There's a great mobile app you can download. And now we're just looking at humidity, one of the many features of windy.com. You can also view the UV index, for example. Once again, there's humidity. Another interesting feature of the windy.com. They've got a great mobile app as well. Perhaps check that out. And here's your U.S. Doppler radar map. Here's your shortwave radiation map showing clouds and fog. It's too dark to use the visible satellite over half the country. And here is water vapor. Lots of moisture here moving across northern Arkansas, now into Tennessee, Kentucky, and adding insult to injury. Not good. They definitely do not need rain in a lot of those locations. Here's your recap. Once again, U.S. Doppler radar. I don't know why it's not animated. Let's press refresh. Once again, I would remind our viewers that our internet connection speed is lightning fast here at the Smash News Network, least busted name of news. Will it animate? I don't know. I'm not going to wait for it. Here's clouds and fog. And there's water vapor. Remember, folks, use the water vapor map when the Doppler radar is not giving you sufficient information. That's how we do it here at the Smash News Network, least busted name of news. And thanks for leaving a comment, Sir Giddy615. Thanks for leaving several comments, Sir Giddy615. We do appreciate that. Who thinks we're in a magnetic reversal, although the geologic record does not agree. So anyway, make sure you join us on YouTube as well, by the way. YouTube.com/SmashoMash is where most of our content is located. You'll see videos there that have nothing to do with space weather or Earth weather. Anyway, thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back.